Hi all, I'm Dr. V. Pungode. Today's topic is Unit 4 Group Definition and Properties. What do you mean by group definition? So, the non-empty set G together with the binary operation star is called as a group if the following conditions are satisfied. The four conditions are satisfied: closure property, associative property, identity property, and inverse property. So closure property is nothing but when we take, for example, when we take two elements A and B belongs to a group G such that A star B also belongs to a group G. Then we say that it is a closure property satisfied. So second is associative property. When we take a three element A, B and C belongs to a group G such that A star, B star, C. Associative is nothing but when we change a bracket and write it. A star, B star, C. So first two bracket changes to A star, B star, C. So when both belongs to a group G, it's called as associative property. Identity property. If there exist an elements, one more element exists, it is E, belongs to a group G such that then we can write it as A star, whatever that exists we are saying, no. So that element A star E equal to E star A equal to, so we have taken one element, no. So that same answer you get it, A. So it is called as that A also it should be in a group G. Okay. So that A also it should be in a group G. Then only we can write it. So where E is called as an identity element. So the fourth property, inverse property. For every element A belongs to a G, then there exists A inverse on inverse exists. It is also belongs to a group G such that we can write it as A star A inverse equal to A inverse star A equal to E identity element, you get it. It's called as a inverse property. Some hint we have to remember when we have, for example, when we have only associative property satisfied, we specially say that it's called as a semi-group. When only identity element exists, we say that it is called as a monoid. Inverse only exists, then also it is a group. Then only commutative. Commutative is nothing but additionally 4 is for group plus additionally commutative it is satisfied means 4 condition group plus commutative, fifth condition, 4 condition plus fifth condition commutative. If it is satisfied, then we say that it is a abelian. Commutative is nothing but A star B equal to B star A. So these are the 4 hints we have to remember it. For that we have some example. It may be asked in the MCQ. So when Z is nothing but integer, Q is rational number, R is nothing but real number and C is a complex number. All the 4 are grouped under addition operation. G is nothing but when 1 comma minus 1 is a group under multiplication. And G is nothing but plus or minus 1 and plus or minus I is a group under multiplication. So this will be asked in a MCQ question. So we'll be doing problem under group also in the next video. So the properties of group. We have 5 properties. Sometimes it may be asked in small question, 4 mark question or 3 mark question. So that is why the first property, the identity element of a group is a unique. Identity element of a group is unique. First identity element is nothing but E. Okay. So it's unique we have to prove. It's unique, it's nothing but it's different. Different means how can I say different? When I take 2 elements only, I can say it is a different. E1 one element and E2 the second identity element. When I say it E1 equal to E2, it's unique, we can say it. So that only I am going to prove it. First I will take, there is a I will take 2 identity element. Let there be a 2 identity element in a group G. identity elements in same G star is nothing but E1, E2. Two identity element I have taken. We know that E1 is an identity element. Is an identity element. And E2 also belongs to G. Okay. If it is like that, we can write it as E1 star E2 equal to E2 star E1 is nothing but E2. Same way, if E2 is an identity element, instead of property, you remember, no? Identity property, what is the property? Third property, you remember, no? That way only I am writing. There we have used A star E, okay? But we are writing in terms of E itself. E belongs to G. Then how can I write? E1 star E2 is nothing but E2 star E1 is nothing but which belongs, that will be the right answer, E1. So from the 1 and 2, check 1 and 2, check it. What it is? E1 equal to E2. So it's unique only. So we have proved. Like this simple. It's very so easy to prove. So this is unique. The next second property, the inverse of each element is unique. Inverse also it's unique we have to prove. Inverse means it's nothing but what it is. There we have taken A inverse. So I will use here some other element so that you will not get confusion at all. So I will take some other element. So let B and C are the inverse. Because already A it is given in the question. A belongs to G. Everyone know it is belongs. One element belongs. So simply B and C are the inverse of A belongs to G. Okay. So inverse, how can I write? Inverse is nothing but A star B equal to B star A is nothing but what it is? E identity element. You remember the inverse definition, no? Now, first element I am taking A inverse, there will be writing A star A inverse equal to A inverse star A equal to E will be writing. Instead of that A inverse, there is a inverse. But here B is the inverse we are taking. According to that we are writing. This is first equation. Same way C is the inverse element. Then we write it means A star C is nothing but C star A equal to E. This is second equation. Okay. So now we have to prove B equal to C. B equal to C only we have to prove. Then only it is unique. B and C are the inverse, no? So both are equal means it's a unique. Okay. So how can I prove it? So now what I am going to take? First I will take B. B only I will take. B if I take it. So B can be written as E star B. Correct? So because any identity element when it is multiplied with E, I will be getting the same. Correct? No. So that only I have written. Now, so E is nothing but any one case I can use. E is one from 1 or from 2. Any equation I can use. So I will use E is nothing but C star A I will use. Okay. So E is nothing but C star A star B. Okay. From 2. Now what I am going to do? Now we know that. Okay. So we sorry C no I have written E. Change it. This is C. From 2. Okay, C star A star B. Now I can change the bracket using associative. So C star A star B. by the property associative. Now A star B, where it is, you check, A star B is nothing but E. So C star E by 1. C star E is nothing but C. So we have proved B equal to C. So both the inverse are unique. We have proved it. So this is the way we have to prove for the second property. So the third property is nothing but the cancellation law. The cancellation law are true in the group. Both the cancellation law are true. When cancellation means it's nothing but left cancellation is there, right cancellation is there. So left cancellation means you see here, left hand side will be the same element. Here right hand side will be the same element. I can cancel it. This I can cancel it and write it as B equal to C. So that is called left cancellation law. Right hand side, the position when you have a same element, it's a right cancellation law. So how can I prove it? So now for that proof, so when I take, first I will take A star B. So assume A star B, I am taking equal to A star C. When I prove it for one, it is same for the another right cancellation also. Only one I can prove, I will write it's similar, we can write it. It's not wrong. Okay. So now we know that. So I can throughout multiply it by A inverse. Multiply by A inverse. Multiply by A inverse throughout. Okay, when I multiply it, what I will get? A inverse star A star B. It's like a pre-multiply. Okay. So A inverse star A star C. Okay. So multiply. Now change the bracket. As per the associative, I can change the bracket. As per the associative, change the bracket in both left and right. I have changed by associative. By associative property changed. Okay. Now we know that A star A is nothing but E by which property? Inverse property. These are not familiar because they told it is a group. Cancellation law are true in a group. So all the group definition you can use it. So E star B is nothing but B. E star C is nothing but C. From which definition? Identity. By identity, it is B. By identity, it is C. So, B equal to C. So, left cancellation is true. Similarly, right cancellation also, it is true. B star A equal to C star A equal to B equal to C. Okay. We need not take time. If it is a 4 mark one, you prove the remaining, the same procedure, you repeat and write. Okay. The fourth property, A star B, the whole star, the whole inverse is nothing but I have to write it as B inverse star A inverse. Okay. So now, how can I prove it? First I will take, so now it is given A star B the whole inverse. Okay. So now before taking that, I will multiply A and B are belongs to on a group G, that we know. Then closure property satisfied. A star B also it's a closure property. So first I will take it as A star B star B inverse star A inverse. This I will take it. Okay. When I take it, I will change the bracket A star B star B inverse into star A inverse associative. Okay. Now A star E star A inverse. This is by inverse. Now E star A inverse is nothing but E by again identity. Both time identity. A star E. This fully is E. Again A star E. Again E. Okay. So it is by identity. So now I have proved it is a E. Okay. So now same way I will take it opposite way. B inverse star A inverse into star A star B. Why I will say, why only I am taking this. B inverse, now I will change the bracket, I will change it. A star A star B. Okay, this is nothing but same procedure. E star B. So change the bracket. This both is nothing but B inverse star E. B inverse star E is nothing but same E. Okay. So same rule only. Now what is the meaning means, now I have proved. So when I prove it, inverse only. So it is a given inverse means. So what is our inverse rule? Inverse when I write it for a star B, when I write inverse is nothing but B inverse star A inverse. Okay. So it is nothing but. So you remember the property, inverse property. What is our inverse property? A star A inverse equal to A inverse star A equal to E. Okay. So this is only our inverse property. What it is? One A inverse only I have to prove it. For that I am taking A. When I multiply it, I am getting both the answer. E means it is inverse property satisfied. Now you check it. This is our inverse. This is our inverse. Same way. Like A inverse, this fully A inverse. Instead of A star B, I have taken equal to E, I got it. Same way, A inverse is this, A is this, equal to E. So what is the meaning? So A inverse is the inverse. Instead of that, B inverse star A inverse is the inverse. So it is proved. So it is nothing but A star B, the whole inverse is nothing but V star A inverse. Okay, this is the way we have to prove it. Link with your group definition. Everything with the group definition we can prove it. Okay. The last property is very so simple. In any group, the identity element is only the idempotent element. Idempotent element means it is A is the idempotent element. A is already we know that idempotent element means A. Okay. So we know that A star A is nothing but A because it is an idempotent element. Now I will take E because identity element means E. E I will take. Identity element means is E. Okay, E is nothing but how can I write A star A inverse? Okay, because identity element A star E is nothing but A star A inverse. I can write it. Okay, now I can write A star. What I have written, this I have used. This I keep it as first. From first, this A I have written A star A. Okay. A, only one A can be written A star A. So now change the bracket A star A inverse. Okay. So change the bracket using associative. To understand only I am writing how it's coming. A star, it's nothing but E, okay, by A star A inverse is nothing but A star A inverse is nothing but inverse property. A star E is nothing but identity. It's nothing but A. Okay, now we have proved E equal to A. What it is given in the question? Identity element E is only the idempotent A. Yes, it is proved. Okay, so this is a way we have to prove it. Thank you.